Hello guys, today we are going to solve this question. It says the circuit diagram in figure 10.27 shows a 12-volt power supply connected to some resistors. The current in the resistor X is 2.0 amperes and the current in the 6.0 ohm resistor is 0.5 amperes. Calculate the current in resistor Y. So current moves like this in the direction of the longer bar and continues like this. This is the junction here, and when current moves like this and gets here, it splits into the upper part and the lower part. So we can call this this current I1 and call this current I2, this current I3. So to solve this equation, we must apply Kirchhoff's first law. It says the sum of currents entering a junction in a circuit is equal to the sum of currents leaving that same junction. Is it clear? This is the simplified form. Total current entering is equal to total current leaving. Here you understand that a junction functions like a funnel. The amount of water entering a funnel must be equal to the amount of water leaving the funnel. That is a simplified form. Current entering a junction is what? I1 equals to current leaving that same junction is what? I2 plus I3. I hope it's clear. So how do you get I3? This I3, how do you get it? I3 will be equal to what? This I1, when this is positive, when this positive number crosses here, it becomes negative. So it becomes negative I2. So I3 will be equal to what? I1 is what? 2.0 minus I2. I2 is 0.5, which gives what? Which gives this 2.0 minus 0.5 gives 1.5 amperes. So that's the answer of the A part. Okay, the B part says the resistance of the resistor Y. So how do you get that? Of course, you must use Kirchhoff's second law. The sum of EMF around any loop in a circuit is equal to the sum of potential difference across the loop. The simplified form says the total voltage of batteries is equal to total voltage of resistors. So here you need to get the total voltage of each of the batteries and that of the resistor. So how do you proceed? You proceed by identifying your loops. So you need a loop like this. So you will take the first loop and you take this to be the second loop. So you call this loop 1 and loop 2. So in this case, they're asking for the resistance of the resistor Y. How will you proceed? You can go directly and use loop 2. So here we use loop 2. So here you assume the clockwise direction. So the clockwise direction goes like this, like this, like this, like this, and this. Here clockwise direction goes like this, like this, like this, and like this. This is the clockwise direction of the first loop. and clockwise direction of the second loop. This is loop 2, this is loop 1. Applying Kirchhoff's second law, total voltage of the batteries equals to total voltage of the resistors. Is there any battery here in this loop? No. So it's what? 0 equal to what? Equal to total voltage of resistors. So where are the resistors? This is the first resistor here. This is the second resistor. And remember, voltage is equal to current times the resistance. So current moves like this. The current is like this, and the loop is clockwise in the same direction, so it's positive. So it's positive resistance and the current. The current here is I2. Next, this resistor here. Here the current moves like this and goes towards the right, and the loop goes towards the left. So they go in opposite direction. So it's minus. When the current moves in opposite direction as the loop, is negative. And when the current of that resistor or battery moves in the same direction as the loop, it is positive. So here it moves, the current moves in the opposite direction as loop, current like this and loop like this. So it's negative what? Y I 3. And you know that 0 equals to 6. What is I2? I2 from here is 0.5 minus what? What is I3? We got it here. Times Y. And I'm looking for Y. Now Y then will be equals to 3 over 1.5, which is equal to 2 ohms. The C part says the resistance of the resistor X. This is the resistor X here. So how do you do it? You apply Kirchhoff's second law again. The total voltage of the batteries is equal to the total voltage of the resistors. So how do you get the total voltage of the batteries? There's only one battery in this entire circuit, or in this loop here, which is 12. Is it going against the loop or in the same direction as the loop? Because we need to determine the sign. So is it going against or towards the loop? Current from the battery is going towards the left, and the loop, the clockwise loop, is going towards the right. So it's opposite direction, so it must be a negative. Negative what? 12. There's only one battery, so that's all on the left. Then equal to, on the right you write what? The total voltage of resistors. So there are two resistors here, this and this. Is the current passing through it going the same direction as the loop or not? In this resistor X, current here is going like this, and the loop is going like this. Current here is going to the right, and the loop is going to the left, so it's opposite direction, so it must be a negative. Negative what? The resistance of X multiplied by the current of what? X. What is the current of X? It's I1. Remember from this formula here, V is equal to IR. You only work with the voltage of both sides, for the battery and for the resistors. But now in this loop 1, there's still another resistor again. This resistor. Remember, this resistor Y is not in the loop. The current here is moving towards the right, and the loop is going towards the left, so it's opposite direction. So it's minus what? 6. Its current is I2. 6 what? I2. So now you're looking for what? Rx. This is known. So I just substitute, becomes then Rx will be equals to this negative cancels negative, and you're left with 4.5. Resistance is measured in ohms. So that's the final answer.